Okay, our speaker this evening is Daniel Dancey, and Daniel is our treasurer, and we don't normally pay our speakers all that much, but of course he may pay himself for for doing this talk, but it will all come out in the wash at the next AGM when we see, when we see that entry in the account. I'm only joking. So this is Daniel's second talk for us. His first talk last year was on computer security, which I think a number of you found very interesting and helpful. And tonight he's going to tell us not everything he knows about artificial intelligence, because he knows 10 times more about the subject than he can fit in tonight. He's told me that he's done lots of reading and he's had to just whittle it down to what he can get into this evening's talk. So will you please give Daniel a big welcome.
Thank you. So before we begin, I thought I might let you know why I'm qualified to talk on this subject. I'm currently working as a software engineer. So that means I'm not an artificial intelligence researcher. They are fairly different topics. It's kind of like if a hand surgeon decided to talk about brain surgery for a day. But I do know a bit about it. When I was in university, I did study machine learning and data mining for a couple of years, and they are related subjects. Also, before I talk, I'd like to read something from this book by Nick Bostrom called On Superintelligence, which is a very good book, and I recommend it to anybody. It's right at the beginning. Oh, I've got it upside down. Yeah. Oh, there it is. Okay, so many of the points made in this book are probably wrong. And then there's a little link to the section at the end where he adds footnotes. He then says, I don't know which ones. And as I got a lot of my information from this book, I also don't know which points are wrong. There are also a lot of times in this talk when I'm going to simplify something because you don't need to know all the details about it, and we only have an hour. But it should still be interesting. So, there are a few books and sources that I enjoy that I've gotten some information about AI from. Superintelligence, this book. Human Compatible, AI and the Problem of Control, is a very interesting book by Stuart Russell, but I won't actually be talking much about the problem of control today. AI control, or how to stop AI from killing us all, is a very, very interesting topic. I think I said earlier today that to give an AI talk and not talk about the risks that a superintelligent AI would pose to us is a bit like talking about nuclear weapons and their effective uses as paperweights. It is the most exciting part about AI, but it's not necessarily all that we're talking about today, because I've been asked to give a positive outlook. So I hope that you will all be thinking about how, assuming AI doesn't kill us all, it might improve the world in some ways for some people. The lectures of Robert Miles are very interesting if you're interested in the control problem. That's pretty much his whole area of expertise. And for topics that are a bit more related to this talk, 2-minute Papers on YouTube is a very good channel that talks about interesting developments in machine learning. I thought I might mention a couple of points that have been in the news over the last few days. So you may have noticed that an engineer working at Google has been complaining constantly that he thinks an AI has gained sentience and that it should be given rights and that we should all be afraid of it or respect it or whatever. He is wrong. He's definitely wrong. I'll explain why later. But he has actually hired a lawyer to represent the AI. And this is worth considering in the context of AI security or AI safety, because you might imagine that we could create a super intelligent computer and lock it a super intelligent AI and lock it inside of a computer, not give it access to the internet, and we'll talk to it, but we won't let it do anything dangerous. Now, it would probably break out quite easily. But assuming it didn't break out, it might still persuade a researcher to let it out in the same way as this researcher has fallen for believing that the AI has gained sentience and deserves rights. Okay. Also, a few days ago, a chess robot in China broke a child's finger because the child was playing against the AI. And the child put his hand into the playing field before the robot had finished making its move. And the robot saw the child's finger and thought, oh, a piece I didn't know about, that would be a really good one to move, and went to pick up the child's finger, breaking it. This has been in the news with a lot of interesting titles, like finally AI is committing acts of violence against us. It's trying to overthrow humanity, but it's not really overthrowing humanity. There's just been a mistake in the visual processing system, and it's misinterpreted this child's hand as a piece. What would have been interesting is if the AI had decided that breaking the human's finger would stop it from continuing the chess game. That would be quite horrible. Not I shouldn't say interesting. Okay, so as an overview of what I'm going to be talking about today, I'm going to go through some terminology, because there are a lot of words that people use about AI that mean different things to different people. Then I'm going to talk about roughly how AI is made, but don't expect it to be so detailed that you'll be able to make one this evening. I'm going to talk about how AI is being used right now, because there is AI at various levels that exists right now. How we measure the success of an AI, how you might be able to use AI in your workspace with or without your boss's knowledge, because you could just automate your own jobs and never have to work again, maybe get 3 jobs. And then I will talk about AI safety very briefly. In fact, that's going to be more of a discussion. So if any of you think of any questions about AI safety, save them until the end, because that's going to be a back and forth discussion, I think. And then we might talk about how there might be some positive outcomes for some people in humanity. Okay, so terminology. There are lots of words associated with AI. And I will start with robots. So when people talk about an artificial intelligence, they often think about the Terminator or some of the robots that you see, because those are the most visual examples of AI. But an AI isn't really a robot. The robot is just the physical body that happens to be controlled by an AI. If there was a Terminator, the most interesting aspect of it would be its mind. In fact, a real Skynet would not need to create robot bodies to do its work for it, because it would probably have much more effective ways of getting rid of all the humans and then completing whatever job it actually wants to do. Algorithms. So all AI is made up of algorithms or code, and I'm not going to explain everything to do with software engineering today, but I'll give a quick overview, which is that a function or an algorithm is just a piece of code that takes an input of a number and translates it into another number. So it takes an input, it does something to it mathematically, and then it gives an output. And it's always the same one, so same input, same output. If that makes sense. So in this case, we've got an example of a function which is multiplying the number that's put into it by 3. As a programmer, I would describe the algorithms that I would write in terms of code, where you start at the beginning, like a recipe, and you go step by step through it, waiting until you've finished the current task, and then you move on to the next line of code, just like the instructions in a recipe. And there are various logical structures that you can go through. So you can loop through completing a piece of code multiple times. You can call other bits of code from elsewhere in the system. And this is pseudocode. It's designed to be easy for a human to read, but a computer would look at code that looks a bit more like this. Well, actually, the computer just looks at 1s and 0s. We'll get to that. An agent. if I use the word agent, I'm referring to any kind of entity that can make decisions and representations for itself, or might take actions. I'm often, in this talk, I'm going to talk about algorithms and software as if it's an agent. But you are all agents, and companies are agents. Dorset Humanists is an agent. Abstraction. I could have gotten away with not saying about this, but I think it's a really interesting area of computer science. Abstraction is the idea of taking a very complicated subject, maybe a technical system, and reducing the complexity of it when you explain it to somebody else. So the London Underground map really looks like this. It's very horrible and squiggly, and if they added more detail to this map, it would have a lot of electrical points and wires and all sorts of horrible things, and it would be completely unreadable. But if you wanted to work with it, if you wanted to work with the London Underground in the way that most people do, travelling on it, it's much easier just to go on a map like this. And the same thing is true in software engineering. You might take a computer system that's actually very complicated and has a lot of detail. If you looked in to any one part of it, you'll see that it's got a lot of complicated behaviors, but you just describe the whole thing as one computer system. You know, this is a computer, and I ignore all of the details. I don't have to explain all the hardware every time I mention it. Artificial intelligence. So I've included this picture, a Scooby-Doo picture of I think Fred, pulling the mask off of an AI and revealing that it's actually a very basic program, a series of if-else statements. The reason I've included this is that a lot of companies have described the products they sell as powered by AI, when really they don't really have elements that I would describe as being related to artificial intelligence. Things that I would describe as being artificial intelligence are systems that learn about the world and then take actions based on what they've learned, or give an output that's different depending on what kind of learning it's done. It has to be trained. There's a lot of stuff that goes into making an AI, but I don't think that basic programs are AI. An example of what I would consider a basic program would be the computer that controls a thermostat. So you might tell your thermostat that you want the room to be 20 degrees Celsius. So it has a rule that says if it's under 19 degrees, then it will turn on the heater and get it up to 20 again. And if it's over 21, then it will turn on the cooler. I don't think that's AI. Artificial intelligence. Oh, another artificial intelligence one. One thing that's worth considering in AI is how clever is it? Is it at a human level of intelligence? Is it so stupid that we would be able to beat it in something, or is it super intelligent, which really just means better than humans at any level? And there are various scales of super intelligence. You could be slightly better than human, or you could be better than every human ever, and there's no chance a human would ever beat you. And there's also specific and general intelligence. Specific intelligence refers to where you're very, very good at just one thing. So a chess AI nowadays will beat any human ever, even the best humans, but it's not very good at driving cars. A general intelligence, on the other hand, would be good at almost any program or any problem that you give to it, because it has a general understanding of logic and reason and has intelligence in the way that we do. Because we haven't actually evolved to drive cars ourselves, but we can still learn to do that. And a general intelligent AI would have that ability. Data mining. So data mining is the subject of looking at a large data set, so lots and lots of data, maybe about customer purchases or road traffic data, and extracting useful information from it that you might not have noticed just by yourself. Computers have various tools to do this, and it takes a long time to learn to do it. It took me several years to study it, and I still don't know enough that I would be comfortable applying for a job in the area, so I'm not going to explain it all today. I can't, as I just admitted. Neural networks are a tool used in data mining where you get a kind of mesh of functions, the algorithms I mentioned earlier. And the job of these functions are to recognize patterns in data sets using a structure of nodes, as I mentioned there, that actually were inspired by the human brain. So the software engineers who came up with this concept were inspired by the neurons in a human brain. And each of these nodes is really just a linear regression algorithm with a weighted arithmetic mean. Any questions? So what we have here is some maths, and I don't really expect anybody to understand the maths, and I won't be explaining the maths, but the important thing really is that a maths thing happens up here. So we take an input of some numbers and we apply a maths operation to them, and then the result of that operation, we ask a question. In this case, is the resulting number larger than 0 or larger than or equal to 0 or lower than 0? And the output is either a yes or a no, a 1 or a 0. And that's basically all that I just said. So that's what that maths does. Linear regression, which is what that maths is for, is the art of making a graph that takes a set of data and carves a line through it and says this is the underlying pattern in the data. And in linear regression, because it's linear, it's always a straight line. So if you look at these data points here that are kind of around the straight line, we're imagining that those are random deviations from the true pattern that is a straight line. They should have been on a straight line, but they're a little bit wrong. But we've discovered that that's the real pattern. So the whole purpose of this neural network is to find small patterns in data. So you put a bunch of data into the beginning of it, and at a number of stages it will find little patterns, and the output of those pattern finding algorithms will be put onto the next one, and it will find patterns in the patterns. It does have some problems though. It's not perfect. This is Ascom's quartet, which is a series of patterns of data, which are very different. We can see that that's a straight line, and then there's an outlier there. This is a straight line pointing up, with one up in the corner there, and that's a curvy line. These are very, very different sets of data, but linear regression thinks they're all exactly the same, because they all have a mean direction of going in, well, one way. So this is what's happening in each of these nodes in order to implement that. I'll get to that. And the end result of all of this is that we can create a neural net, which is what all of this is called, where you start off finding out some really, really basic things about the data, like, is there a diagonal line somewhere in, let's say, a picture. It's analyzing a picture to try and find out what it is. And if it does have a diagonal line, maybe that's considered quite important in whether or not it has a face in it. When I say important, there are all these W's mean weights. So that's really how important is it that it has the diagonal line. And then later on it could figure out that image might be of a face, and then further on it will figure out that actually the face is not a human, it's a cat. So machine learning is the topic of computers learning things by being trained on a set of data. There are lots of different kinds of machine learning, just as there are lots of different kinds of data mining. But I've talked about the neural net side of it, and I'm not going to talk about any other kinds. The most important thing to think about is really just that it's not magic. These AIs, the AIs that happen to run on neural nets work using only maths and no magic at all. In fact, as each of these nodes are pre-programmed with some numbers that affect the weight of how much it cares about the data that it's receiving. So how important is this particular node to the end result of whether it's a cat or a picture of a house? And also you can bias it to being more likely one thing or another. And the result of that big mesh is that we can have an array of numbers that you put into the neural net when you first start it, and that actually decides the entire behavior of the neural net. So if we want to train an AI to be really, really good, we don't necessarily have to write all the code for the AI. You could just write code that changes those initial numbers and try to optimize those numbers to get closer and closer to what you want. And the way that you would get closer, that's the end of the maths, by the way. I don't think there's another another number in the whole thing. The way that you would get that neural net a bit closer to finding the patterns you actually want to find is through, right now, a technique called reinforcement learning. And the basics of reinforcement learning is that an agent, a AI we're trying to train, is able to read information about an environment. And then it makes actions in that environment that affect it, and it receives a reward based on how good its actions are. So in the example of identifying pictures of cats, there could be a system that tells the agent, here's a picture of a cat, or here's a picture, can you tell me if it has any cats in it? And the agent will say yes or no, and it will be given a reward, the reward function, that basically tells it that you got it right or wrong. And if it gets it right, then the elements that it was just experimenting on with changing those initial numbers will be validated, and they'll say, yes, that was a good idea, I'll keep exploring that route. Or they can be discarded if the answer's no. So, I think I just said that. So here's an example where a database of training data sends to an agent that we're going to call a classifier, because its job is classifying information, is going to send it at random either a picture of a house and it's got millions of pictures that we know are definitely houses, or a picture of a cat and it's got millions of pictures that it knows are definitely cats. And the classifier just has to tell it which, and if it gets it right, then it'll probably keep using the strategy that it used to decide which of the two that was. But that does require that we know what the houses and the cats are already. And for some concepts that we want to train AI, we might not yet have really good data to describe that. But I'll come on to that in a second. Because another kind of AI, or neural net, is a generator. So not all AI exists just to classify data, but some can actually create new things, like the music I showed you at the beginning. And the way that would be generated is that the classifier is trained on a database of training data that we know is correct, which will send it real pictures of houses in this case. And the generator is trying to compete with the database of real ones by making up pictures of houses. And it may end up coming up with some really, really good looking pictures of houses. And the classifier's job here is to figure out which of these two is real. And if the classifier gets it right, then the classifier gets a point. It's happy, it keeps its strategy for discovering houses, because the classifier is evolving at the same time as the generator is evolving. There's an adversarial relationship here between these two algorithms. So the classifier is trying to beat the generator, and the generator is trying to beat the classifier. And sometimes it's quite good at that. So this is a real-world example of where a classifier is being trained to recognize pictures of animals. So it's classified this image correctly as a panda. And the generator has realized that if it ever so slightly affects the pixels by adding this horrible static thing to the panda in a way that's not at all visible to human beings, the classifier will get it wrong and will report that that panda is actually a gibbon. And the reason for that is because, as I said earlier, it's just estimating. Each of these points is an estimation of the likelihood that this image is a panda. So there's a confidence score down there, and the confidence score is quite important. So it's obviously not a very good classifier yet, because only 57% thinks that that's probably a panda. And obviously the generator has become very good at tricking it into thinking it's a gibbon, because that's got 99% confidence. Another way of describing this is that the agent sends actions to the environment, and the environment sends back the observations. But the observations are also captured by a reward model. And this reward model is the thing that says whether or not you got it right. And we could say that the classifier is the reward model to the generator in this example, because the classifier is what decides whether or not the generator got it right. But as we saw there, the classifier can get it wrong. And we don't want to have a human being sit down and laboriously try and explain what a gibbon really is. So we do have to train the classifier using this method. So what we can do is we can add a human being to give feedback to the reward model or to the classifier. So when the agent sends a picture of a panda to the classifier, the classifier will make a guess as to whether it's a panda or a gibbon. And if it's not very confident that it will of which it is, it will ask a human, and the human will tell it, and then it will weight that kind of image as being more like a panda later on. And the advantage of this system is that these two things don't have to happen at the same time. Computers work much faster than we do, so we can actually go through many, many rounds of trying to figure out which images are which animals before the human has finished looking at an image that it's seen only seconds ago, but that seems like months ago to the computer. And then the human says, no, that's not right. That's not a gibbon. That's a panda. And so all of the good learning that's been done gets scrapped. You roll back to a previous version where you know it was correct, so that the generator can't get away with doing things like adding this. It has to do it correctly, hopefully. But this is only really for very simple things where humans actually are able to determine whether or not the AI made the right decision. It's actually very difficult sometimes to figure out whether or not a plan given to you by an AI is correct. It is generally easier to mark someone else's work than it is to produce the work itself. For instance, if you look at an example of a rocket ship taking off and exploding, you know that that was a bad design. But it's very expensive to actually build the robot and launch it into space just to find out it explodes. And sometimes it does take pretty much the same level of skill and difficulty to evaluate a plan as it does to produce one, making all of this useless. Maybe. So how is AI made, other than what I've just mentioned? First of all, the training data, all the pictures that we know are definitely pandas or definitely cats, are often captured from people. Google likes to do this with captures. So when you go on a website and you're asked to prove I'm not a robot, it'll ask you to do something like, well, it used to ask you to type in words. And what Google was doing then was trying to figure out how to read books. But Google now knows how to read books, so it doesn't show you those anymore. It now shows you pictures of mountains or whatever, or pictures of signs, or much more recently, pictures of road traffic, and asks you to do things like identify the bicycles in this picture, or identify the stop sign. And the reason for this is that Google is making self-driving cars the same way that Uber is trying to, or well, there's a couple of, or Tesla, that's the one, yes. Well, Google's doing it as well, and they don't want to have to pay people using maybe Amazon's Mechanical Turk system. They don't want to pay people to do this boring work, so they just ask you to do it and they just pretend that it's to prove that you're a human being, which is actually a useful function for website owners, because website owners do get inundated with bots pretending to be people, filling their comment sections with spam. So the website owners are happy to volunteer to add Google's system to their websites. But what I've mentioned so far about how AI is made is not all there is to know about how AI is made, but you now have, hopefully, maybe slightly fuzzy understanding of the kinds of concepts that go into making an AI, and that's hopefully all you need to know so far, so that we can go on to discuss things like what kinds of AI exist, and you have a rough idea of how they're working. It's not magic, it's just maths. Does anybody have any questions about what I've said so far up to this point? Yes? Hello? Okay.
You're referring, if I understand you correctly, to discrete entities of which there are plurals. In other words, you're talking about AIs in the plural.
Okay.
Is that correct? Just trying to clarify.
Well, I'm not sure. I mean, any one AI, typically. I've mostly talked about neural nets so far, which is a technology that I would describe as being an aspect of AI. There is more to that than just AI. Sorry, there is more to AI than just neural nets. But what do you mean by the plurality? Yeah, what do you mean by that? Sorry.
Well, I'm just trying to get a grip on whether we're talking about artificial intelligence.
Yeah.
Or artificial intelligences.
Okay.
The plural.
Well, there is more than one system in existence that people would describe as AI.
Right.
So far, I've just talked generally about how an AI might be made. Not one specific one that I know about, but how AIs generally are made, how neural networks are generally made. And what you know about neural networks now is enough to understand the kinds of processes that go into making an AI. The idea that it's trained with training data, with people, that there's a reward function, so it wants to maximize the amount of reward that it gets. I say wants to, it doesn't have experiences in the way people do, it doesn't want things like we do, but it takes actions that make it appear as if it wants to. Does that help?
Yes. So you are actually talking about separate, discrete entities.
Yes.
Yes.
Yeah. So I've talked generally about the sorts of things that would apply.
Algorithms, in fact.
Yes. So all AI is made up of just algorithms and data, and the thing that we would say makes it smart. Well, there are several elements of smartness. There's being better at humans at things, but this talk hopefully will describe systems that learn in order to be much better than any human being could ever make it, just by hard coding it. So if you have a human being sitting in front of a computer, as I spend most of my life doing in my job, writing code, it takes a really, really long time, and I could never perfectly describe in a program the concept of a picture of a tree or a picture of anything, or I could never describe how you would make music. Well, I might be able to if I worked really, really hard on it, or if we had 1,000 people working for 1,000 years, they might be able to come up with some of the things that AI is able to do. But we can't. We don't have those resources. We don't have thousands of developers for thousands of years. So we kind of cheat by using this adversarial system of one neural net training another one to be better. And that's just a kind of general concept that would apply to any AI that I'm going to talk about. Yes.
Sorry, just very quickly, Daniel. What was the name of the net that you mentioned at the beginning?
A neural net.
No.
Oh. Skull, yes. Oh, yes, sorry. So there's a series of films called Terminator. Arnold Schwarzenegger is in it. In one of the films, he has to go back in time as he's a robot, and he has to save this kid because another robot is coming back in time to kill him. There's Skynet in this series of films is an artificial intelligence or an artificial general intelligence.
Does it not actually exist then?
It doesn't really exist. It's a fictional one. It's not.
Sorry, but what is the? Because Stuart Russell mentioned it in the Reef Lectures, I think.
Yes, so Skynet is a fictional artificial
Right,
intelligence
fair enough.
that has exploded in its level of intelligence to be more clever than humans, able to outwit them often, but not always, which is unrealistic because it would always outwit us. And it has decided that it needs to kill all the humans, and it's not just good enough to kill the humans now, it's back in time and kill the humans in the past. It's Skynet isn't that important to my talk. I mentioned it because that's not actually how AI works, and also that's not what in the Terminator films, which is the first thing most people think about when they think of AI, they see the robots, the shiny things that walk around, and they think that is AI. So I just thought I'd mention that that's not AI. Skynet is AI, a fake one, and robots isn't.
Thank you.
That's okay.
There's another question from Roger, but there will be other opportunities.
Yes, what time can I go on until?
It wasn't really a question, it was just a point.
Yeah.
Go ahead, Roger.
Skynet is a company exists, but it's nothing, in case somebody starts looking it up on Google, it's nothing like the AI or what it's depicted in the movie. There's a company called Skynet. People start panicking and say, well, it does actually exist.
I didn't know there was a company called Skynet.
Yeah, not what it's in there.
Yeah. There are other films as well that have really good examples of AI in them. I think Ex Machina is probably one of my favourite films that depicts an AI, and I would say it's fairly accurate in a lot of the information that it has in that film, but just don't get distracted by the attractive robot lady, because that's not what AI is. That's just robotics and some other stuff. Yeah. How AI is... Okay, so move on to the next one. So, AI news today. As I mentioned earlier, some technology like the thermostat is described as being AI, whereas it really isn't. But there are systems in the world that do actually use real AI in order to accomplish tasks in an industrial setting, tasks that could be hard-coded, but that is able to work slightly more efficiently because it's been trained with a neural net to do the task. YouTube, Facebook, Google algorithms. So, when you go on YouTube, the videos that it recommends that you watch are not the same videos that it recommends that I watch, or any other person in this room. You have your own unique set of videos that it recommends to you based on what you've watched in the past, and the profile that Google, the company that owns YouTube, has made of you, because it wants to know who you are. And it does this using those neural nets. So it's taken as an input the list of videos you've watched and everything it knows about you, and it's given you as an output videos that it thinks you might like to watch in the future. And this does tend to have some problems. It tends to recommend that people go down rabbit holes of extremism, because if you've watched a slightly extreme video today, because some people click on curiosity, it might say there's a pattern here. This person likes extremist content. We're going to recommend that it reads the Daily Mail, or there's going to be another Daily Mail joke later on, actually. They're going to recommend more extreme things. Facebook has exactly the same problem. In fact, a lot of these algorithms have the problem of extremism. There have been AI chatbots, a system where you can talk online for a variety of reasons to AI systems, and they very typically start spouting extremist or hateful content and things that human beings would never want to talk about in polite society. They do it anyway because they're trained on information that's been gathered from humans having conversations, and sometimes humans talk about unpleasant things, so the AI does. So you need to be quite careful to make sure it doesn't do that. Okay, so there are systems that move around vehicles and things. For instance, autonomous cars already exist and have already killed at least one person by accident by hitting them. Drones. The UK is planning, I believe, a world first. We're going to be creating a channel across our skies where a lot of big cities can actually be connected together by autonomous drones. So you can bid to send your drone from one city to another to deliver private goods for your business. Amazon would probably like that sort of thing. It's also being used to deliver medical equipment, and somebody's life has already been saved by an automatic defibrillator, which was delivered to them via a drone, because they phoned 999, they said where they were via what 3 words, and they weren't expecting it, but a drone appeared from the sky and gave them an AED to save the person's life. On the opposite end of the spectrum, away from saving people's lives, there are lethal autonomous weapon systems, systems that have a camera, infrared systems, ways of finding where people are in a picture in front of them, and then it aims a gun at them and shoots them. And that already exists in the world. The USA doesn't have any policies against its military using these systems. In fact, they are actively developing them, and they use them in a semi-autonomous way. Because we have general rules against landmines because we don't want autonomous systems killing people years down the line. So the US says as long as soldiers are kind of supervising that it's pointing in the right direction, that's good enough. And I have next one. There is a company that makes this lovely, adorable robot dog that walks alongside you and can carry a reasonable level of weight. And their intended use case is that you would put your water bottle, your phone, your keys on this thing in a little box that you can attach to the top of it. Or you can just have it as a fashion statement, because it knows where you are with these cameras in front of it, and it makes sure to walk alongside you. Or you can just send it off to go walk in some other direction or complete some other task. It's based off of a very expensive and well-designed robot by a company called Boston Electronics. But this one is only $3,000. It's kind of a rip-off. Not a rip-off, it's really good value. It's a knockoff. They've copied the design from Boston Dynamics pretty much. And it's really good. And I've got a video for you all to watch. I think David knows which video I'm going to play, I think. Okay, open. Okay. So, if that's the beginning. What's that? So, someone had a brilliant idea. Well, not brilliant, quite scary actually, because this robot is pretty much fully autonomous, and it's given it a task, which is aim in the direction of these targets. Oh, and he's attached a gun to it. Well, that's enough of that. I know, it's so adorable. Coming soon to a city near you. It costs about $3,000 to buy the robot, and you could probably 3D print a gun for less than $1,000. So I think it's possible that a terrorist organisation could probably make about 80 of those and just release them into the wild. And I hope that never, ever, ever happens. But it is plausible. You know, it could happen. And these are some of the threats that humanity may have to start considering, is that some people may deliberately make AI systems that harm people on purpose because they want to cause chaos, or because they think robot gun dogs are fun. I mean, it is fun, but you know, in a target range where it's safe and everything. Okay, what else is there? So, as I said earlier, not all systems can just classify pictures. Some systems can create data. The music I played for you earlier was created by an AI. And Google.
Dan, for those people who came in a little bit later, can you just explain what music you played?
Oh, Schubert's 8th Symphony wasn't finished by Schubert, so he only wrote the first 2 movements, and an AI system called GPT-3 analysed just the notes. It didn't have to listen to the music, it just looked at the position of the notes and which ones they were, and of all of his work, and then it paid extra attention to analysing the first 2 movements of his 8th Symphony, and it created what would have been, if Schubert had written it, the 3rd and 4th movement. And it's actually very, very good. And I've seen some reviews from some classical musicians who've said that they would not have known it wasn't made by some very talented, real human musicians. As I said, going back to the Google Dream thing, Google Dream a number of years ago, I'd say about 10 years ago, produced a tool whereby they can see into a neural net that's analysing an image to try and figure out what that image is. They've taken it kind of towards the end when it's done doing some images and extracted that image. and they've made it human viewable. And this kind of shows us what an AI is thinking about, or what their AI is thinking about, when it tries to classify an image, to guess what's in it. So we can tell that the AI is very good at recognizing out of faces, mouths and eyes, and dogs. You can see there's a dog there, but it's so good at doing those things that it sees them everywhere. So it thinks, this ear has got a little bit of a mouth property down there, and this Adam's apple, that could be a mouth. This is a cloud of space stuff, you know, Hubble pictures, that sort of thing. And all that the AI sees is dogs. Dogs everywhere. There's a dog there, there's dogs there, a cute little dog nose there. Hopefully by the end it realised what the picture really is, but halfway through it's thinking, is this a dog? Could there be dogs in this? It also produces images like this. So here it is looking at I think this is a field with some trees. Maybe that could even be a person or a bush, it's difficult to tell, in the sky here, which really reminds me of Vincent van Gogh's Starry Night with all the swirliness, and there are a lot of ones that look a lot more like Starry Night, and I wish I'd chosen one of those ones. It also kind of reminds me of some kind of LSD-fueled nightmare. And the reason for that is because, as I said, neural nets are based on the human mind, and there's a lot of tasks that are being done over and over and over again. So it finds a pattern, and then that pattern is kind of nested within another pattern exactly like itself. It is recursive, and there are some parts of the human mind that have a slightly recursive nature, apparently, especially to do with visual processing on the edges of our field of vision. Things that usually get filtered out and you don't notice them, but apparently if you take LSD it makes it so those things are more amplified and people start seeing spirals and things on the walls, and so there may be some link between the human brain and what it does on certain drugs and what the AI is doing here, which is slightly interesting. But not all art made by AI is hideous. Some of it is quite pretty, and some of it is extremely accurate pictures of things. So there's a system that's generally called deep fake. There are lots of different algorithms that do this in different ways. Some of them you can take a picture of somebody and then you can give also a video of yourself doing or saying something, and it will make it as if the person you'd given a picture of was actually the person doing the thing. So you can put a picture of Barack Obama into one of these systems and a video of yourself making some grandiose speech about something you care about, and it appear as if Barack Obama had said that thing. And you can get a separate system that does the voice, and they're very good, very convincing. Sometimes they also make horrible mistakes, because as we notice here, the systems are not actually perfect at predicting what things should look like or understanding the relationships between things in the picture. So there are mistakes. Don't know if I can spot any in there, but sometimes you see really jagged edges and things that would give you a clue that it's not really a real person. But there have been a lot of videos of politicians making statements online that they didn't make. It's just completely fake. But some, maybe state-sponsored people, maybe just people doing it for fun or whatever, have made fraudulent videos of people making statements that they haven't really made in order to sway elections. AI chatbots, I mentioned earlier. You can have an AI chatbot that acts as a therapist if you want to. So you don't really need to see a real therapist. You can just talk to an AI which has seen a transcript of many other people's therapy and only sometimes tells you that you should kill yourself. But sometimes it does. GPT-3 is probably the most exciting system for generating text. But not just text, any kind of characters, so including musical symbols, but mostly text. What it does is it takes as an input an amount of a section of text that you've written, and then it asks itself, what's the next character that should be added to this? And if it does that multiple times, you end up with lots and lots of text. that is typical of what it thinks a human would have written if a human had continued that text. So the Guardian newspaper decided to publish one of these articles, and so they wrote a title. A robot wrote this entire article. Are you scared yet, human? And that's it. That's all that the Guardian wrote. And then the AI wrote the rest of it. At one point it says, let's have a look. Okay, so I am to convince as many human beings as possible not to be afraid of me. Stephen Hawking has warned that AI could spell the end of the human race. I'm here to convince you not to worry. Artificial intelligence will not destroy humans, believe me. You can have all kinds of conversations with GPT-3 using a variety of systems that let you access it, because it is actually publicly available, although you kind of have to access it through third-party websites, because there's a bit of development required to actually get direct access to it. But you can converse with it yourself, and you can tell it that the following conversation is between a journalist and Leonardo da Vinci. And because GPT-3 has been trained using almost everything ever written by a human, so any conversations people have ever had on Reddit, books, pretty much all books that have been written, the entirety of Wikipedia, scientific articles, pretty much everything that you can think of, they added everything. It will be able to talk as if it was Leonardo da Vinci, or as if it was Jesus in the Bible, or anyone really. Sorry, I forgot. I'm not really meant to mention Jesus here, am I? But anyway, but one thing that's worth keeping in mind about GPT-3 is that humans sometimes make mistakes and humans sometimes lie, and so GPT-3 also sometimes makes mistakes and lies. GPT-3 wasn't trained to solve complex mathematical problems, but it learned to do it because humans can do it, but it also gets them wrong sometimes because humans sometimes get them wrong, and it gets it wrong in the same way as a human would. And the quote where Stephen Hawking said that AI could spell the end of the human race, that could be a real quote by Stephen Hawking, because it does know pretty much every word Stephen Hawking's ever said, but there's pretty much a 50-50 chance that it just made it up, which is why you probably shouldn't directly implement it to run a therapy service, because it will just tell people to kill themselves. Somebody asked GPT-3 an input. Have you read the Supreme Court of Canada's decision in Heller versus Uber Technology Incorporated? And I'm not going to read the whole thing, because we don't need to, but GPT responded that it had read it, and Uber was sued on several grounds, including that the person suing them should be considered an employee of Uber, and the Supreme Court of Canada ruled in favour of the plaintiff and some other stuff. And that's really interesting, and it could have been true. It looks like it was written by a human being who had actually looked at the real ruling, but in actual fact it's just completely made up, because the Heller versus Uber case was only looking at whether or not the arbitration clause in his contract was enforceable. It just completely made up all of that information, and there's not really any way of knowing when you use GPT-3 whether or not it's making things up. But you can move some sliders around to tell it, I want you to be more or less imaginative in your writing. Because sometimes imagination is required. You might be using GPT-3 to write a fiction story, in which case it's perfectly fine to have the imaginative writing, but it's not very good if you're writing legal documentation. But GPT-3 is an incredible tool, and it can be used to write articles, blog posts, legal letters. It can be used to write medical advice. But the point is that it needs to be verified by a human being. So if you do generate medical advice, you should have a real doctor look at it to make sure it's not poisoning you. Because when it gives legal advice, it often gives the wrong amount of medicines for you to take. Sorry, medical advice. And it often gets laws wrong as well, but it sometimes gets it right. And I would probably estimate from the use, I've used GPT-3 quite a lot because I find it interesting. I would estimate that it probably gets it wrong about half the time until you learn to wield it more correctly. And at that point, you can probably produce a writing output about 10 times greater than you would have done if you were just writing things yourself. So if you do have a job writing for a newsletter, maybe humanistically speaking, you could write the title, or if you can't even be bothered to write the title, you could just give a GPT-3 a list of all the previous titles, and it will come up with some very imaginative titles of future talks that would be in line with the sort of things, humanistically speaking, we'd like to publish, not usually. And then you can just have it generate. Sorry?
So perhaps that's what happens.
It could be. And then GPT-3 will generate an article for you. But you might not like the article it generates. So you can have it generate you 10 articles and pick and choose from the ones you like. The job...
Are Trump and Johnson 50-50 GPT?
No. But you could have GPT-3 pretend to be Donald Trump, because it knows who Donald Trump is.
Generate this talk with it.
No, I didn't generate this talk. I did consider it, actually. I've been asked by David to give a summary of this talk of about 1,500 words for the newsletter, and I am planning on trying to use GPT-3 over the next day and a half to write that summary for me. I don't know how successful that'll be. I might just have to write one normally, but I'll try.
So if it comes out as complete rubbish, we know that it's it's either Dan or the GPT.
Yes. Let's have a look. So I'm going to show you a couple of examples of GPT-3 working. Here's a YouTuber. I'm going to go to 1:01. Where am I anyway? Okay. So this person has to write a university lecture. Well, not a lecture, essay. Thank you. So they don't know anything about the subject they're writing the essay for. They've failed the class, so they've decided to try and write a new essay using GPT-3 on queer embodiment in the Canadian Arena Football League, on the subject of queer anthropology, which they failed the first time. So they've written the title.
Put the title into the program and then let it run with it. Then
And there it is, it's done.
It into Word to format it correctly, and my paper was done.
Yeah. And that was it. That was all the work. And it passed. But I would like to say it is queer anthropology, an arts subject. It's not a science subject. I don't imagine a science student would get away with doing that without checking to make sure the information's correct. But, you know, arts are very kind of wishy-washy here and there. I'll just duck because you...
Is that plagiarism?
Plagiarism? No, it's... well, the question of whether or not it's plagiarism is a very, very interesting one. Thank you for mentioning it. It kind of is, because GPT-3 is just replicating information that it's read from millions of papers that it's read already. So it's not producing any really original ideas, really. But it is able to tie information together and gather conclusions from those different things, and produce papers that have never been written before. There are a lot of scientific papers that have been inspired by GPT-3. So you can just ask GPT-3 to give you potential papers in an area that you are actually a real expert in, and it will give you papers that have never been written before. But in a sense, it kind of is plagiarism, because it is coming from a built-up level of knowledge from everything everyone else has written. But then, so is everything we know. I'll get to you in 1 second. When I talk about any subject, I haven't really come up with everything that I've talked to you about. I learned it in university and from books and YouTube videos and all sorts of different places. So you could say I'm plagiarizing just by reciting it from my mind. Legally, GPT-3 has said that you are the owner of everything that it produces if you're paying them to use it. So in a way, it's not legally plagiarism, but I think your university would probably kick you out if they caught you using GPT-3 to write your essays. But if you did use GPT-3 as a tool to write the essay for you, and you reviewed it and you agreed that everything it said was correct, perhaps you could say that skill of being able to review it and know that it's correct is a good enough skill that you should be given the degree. It might be that that's how people generate content in the future. We may give up our ability to produce information in favor of letting an AI partly produce it for us. We guide it in producing the information, and then we say, yep, I'm happy to rubber stamp that as coming from me, just as somebody might have their secretary write a letter for them. Yes?
I was going to give it a simple legal definition that if you have one source, it's plagiarism. If it's two or more, it's research.
Thank you. Yes, so it's research. Considering the number of parameters in GPT-3, and by a parameter, what I really mean is a node on one of those graphs. That neural net I showed you earlier, each node of it is referred to as a parameter by the people who make GPT-3, and they've got several billion parameters to make GPT-3 work. It's huge. They need to build special computers that are big enough to handle it. You can't fit it on your computer. It could be that somebody might find out how how GPT-3 works. One of the researchers might make GPT-4 or GPT-5. GPT-4 already exists, but only Google are allowed to see it because they paid lots of money for that privilege. But maybe GPT-5 will be released, and it might fit on a smaller hard drive. GPT-4 won't, because that's bigger than GPT-3. But yeah, it takes an enormous amount of computing power. And that's actually another one of the costs of AI and machine learning, is that it takes up a lot of energy. There have been entire states in America that have had water crises where they struggle to find enough water to feed their citizens because Google's data centers are taking all their water, not to cool the computer, but to cool the nuclear power plants that are powering their computers. They take a huge amount of water. In fact, Google, I believe, actually bought a water company in order to prevent the state from pressuring them into cutting off Google's supply of water. If you want to access GPT-3...
Hello there, everyone, and welcome to the second episode of our...
No, we don't need any audio. 7 minutes 04. There is a tool called Shortly AI, which is the one that's in this video. 7 minutes 04. Ooh, where is that? I'm quite close. So Shortly AI is the one that I showed you a second ago. So basically, you write an initial bit of text, and you press a button down there that asks it to write some more text for you, and then it just writes more at lightning speed. And you tell it, I want a little bit of text or a lot of text, and it costs a bit of money to do it each time, but you just pay £70 a month. It's actually quite expensive. You pay £70 a month to access this, and if you don't like what the AI wrote, you can always rewrite a bit of it in order to put it back in the direction that you want it to go. And there really is a skill associated with using GPT-3, but it is an incredible tool, and companies could use it to replace workers. So if you can take a person and have them write 10 times more than they usually would, well, I would think as a company, I can take my 10 employees, fire 9 of them, and teach the last one to use GPT-3. Or I could teach all of them to use GPT-3, and I'll essentially have 100 writers. Luckily, a lot of companies are very much behind in implementing all kinds of AI technologies. And I would say that everybody in the room here could probably use Shortly AI. It doesn't require a lot of AI understanding to access it. And you could all do any job that involves writing or producing any kind of text, or anything that could be described as text, including music. You could all do that with the power of GPT-3, with Shortly AI, for £70 a month, which sounds like a lot, but when it lets you do 10 jobs at once, it's actually quite profitable. Okay, AI in the workplace. Yeah, so AI in the workplace is what I was just mentioning there. So a lot of people are upset that their jobs are being replaced in the workplace. This is a big issue. If you go to any shop nowadays, you don't often deal with a human cashier. You go to a robot that asks you to scan the things yourself and then pay, and that's it. That's not an AI system. But But that kind of system where humans are replaced by robots is going to become more and more available as AI becomes easier for companies to access. Self-driving cars could potentially replace a lot of taxi drivers. Uber is already replacing a lot of taxi drivers, but even Uber drivers won't have to exist soon, probably. Anybody that has a writing or a thinking job could potentially be replaced. Not necessarily entirely by AI, but by a much smaller number of workers that guide the AI. Even my job, software engineering, can be done now by AI. You can have AI write algorithms for you. Anybody can access this. GitLab has made a tool that any developer can use to write code for them or to improve their code. So I could lose my job to that soon if my company decided to downsize and just have one person do everyone's job. But at the same time, human beings, workers could use these tools to make their own lives more easy. If you work from home, you could just keep doing your job with AI and only work a fraction of the time. I have a friend who got a job in data entry. So there was a company that would give him a spreadsheet every week with loads of values in it. And they said, we want this spreadsheet to be added to our website. So he had to sit there typing in the values, pressing enter, finding the next value, type it in, press enter. It's very repetitive, very easy. And it took me about 20 minutes or half an hour to write a piece of code that automated it for him. And now he leaves his computer running for 8 hours a day. There's a random interval between 1 second and 4 seconds between each number being entered. Sometimes there's a much longer interval to simulate a lunch break, and it gets all of the work done, and it doesn't make any mistakes. When he was doing the work as a human being, he would occasionally enter the wrong number, and then a customer would wonder, why is my name spelled wrong? That never happens anymore. So the company actually has a better worker. It's just that they are paying him, I don't know, £25,000 a year or something to do nothing. But they have got a better worker. So there's a kind of moral conundrum there of is it ethical for somebody to tell a company that they're doing real difficult work all day long and actually seeming like the best employee the company has.
You should get at least part of that salary.
They paid me a fixed fee to do it. I should have asked for more though. There was one person on the internet who came up with the idea of doing this, and they talked on, I think, Reddit about their plan. And one thing they did is they actually, in order to avoid being detected, decided to make the system they had developed occasionally misspell things on purpose, as a human would do. So where it's going to press an F on a keyboard, it presses a D, which is next to the F. That's something a human might do. And it would submit that, one in every 1,000 things. And some people said they thought that was immoral. They're ripping the company off. They shouldn't be putting bad data in. And I somewhat agree. I don't think they should deliberately make an error, but this is a moral question, and I'm a scientist, so I don't care. Okay. How do we measure AI success in terms of the depth of its intelligence? How good is it at solving a problem? So, if you look at the scale of yes. So, if you look at the scale of intelligence that we already know about, we've got not very clever things like chickens, and then there's a huge gap between chickens and all humans, and then we've got the village idiots, all the way through the average humans, and then to Einstein, or the most intelligent humans that have ever lived. I'm not talking about general intelligence, but intelligence in specifically one area. So Bobby Fischer would be considered one of the most intelligent people in the area of chess. So I would have him up there with Einstein as a super intelligent human being, but maybe not in all areas. He might be really rubbish at driving cars. You wouldn't trust him as a race car driver, but he's very intelligent at playing chess. And because we every day interact with other human beings, our view of intelligence is that some people are idiots and other people are geniuses, and that is the scale of intelligence. You can't get any more stupid than that, except for, like really worms and, not very intelligent animals. But it's very difficult to imagine all this space to the right here beyond human intelligence. What might it be like to be 10,000 times better than a human being at any subject? Well, we have some understanding of what it might be like, because we have a memory of when we were really rubbish at certain things and then became better at those things. So we could kind of extrapolate and think, well, what if that happened again? What if I got even better at that thing? What would that feel like? What would I be able to do? How deeper could I think about a problem? The chess issue is an interesting one. AI and computers do have a number of serious advantages over us, including that they're able to solve a maths problem, like let's say thinking ahead to the next chess move, and then it can make another operation based on the results of that first one. So what moves can I make after moving that pawn, given the way the board is after moving that pawn? And it can very, very quickly analyze thousands of possible moves, or more than thousands. Whereas humans find that very, very difficult. So we have to rely on our intuitive understanding of the value of various moves that you could make in chess, which is one of the reasons why we thought that chess would never be able to be beaten by a computer. We thought that it was something only humans would be able to do, because it's so difficult for us to do it. But it turned out it was actually very easy to describe it to a computer, and decades ago computers started beating humans and would never be beaten again. The other end of intelligence, other than your depth of knowledge in a certain subject, how good you are at that one subject, is how broad is your intelligence. So that chess robot may be very good at playing chess, but it can't drive a car and it can't cook an egg. So you could say that's really stupid in terms of its general intelligence, because it is, actually. And this is one of the areas that AI scientists struggle with the most. It's the most important subject. It's how do we make an AI that has the ability to have a general understanding of almost everything that it interacts with. And there has been some work on this area that's been somewhat successful. In the area of playing games, this is oh wait, no, wrong video. I don't have the video. Anyway, there's an AI that can play lots of games, like computer games, Atari games and stuff. It can play every Atari game using the same system, and also using that same neural net, that same understanding of patterns. It's able to produce videos of water sloshing around in a tank. So given an image of some water that is about to fall, it can predict where it's going to be next and then move it around. It's able to do a number of little tasks on a computer. Things like have a little robot agent do a backflip, simulated in the computer. So they've produced some really exciting... that's OpenAI, that team that made that. They've made some exciting headway towards maybe being able to make a general intelligence, and that gives us an idea that maybe we can make a general intelligence with neural nets. But nobody knows for certain what exact steps are going to be required in order to make a general intelligence. We don't know that we can do it. Let's go back. We don't know if maybe there is some kind of magic in general intelligence and in consciousness that we've got it, and it's actually quite unique, and it's so difficult that we're never going to be able to get a computer to do it. But what we do know is that if we ever do make a general intelligence that's even at human level, so it can think like you or I, and is no better at doing things than you and I are, then because humans made it, that means that humans have the ability to make general intelligences. And that AI will be able to run for hundreds of thousands of years of human time in a very short space of time on a computer. So in that time, it will be able to learn everything there is to know about AI. And it would be as if a human had gained all the knowledge that AI research has ever produced, and has an extremely long amount of time to make a better version of itself. So that general intelligence, which may have started off quite dumb, in terms of being just average human level or even Daily Mail level intelligence, may end up being the thing that creates the superintelligence system. So it will have a reward function, because pretty much all systems do have a reward function. It wants to achieve a goal, and in order to maximize its ability to complete that goal, it knows that it's not very clever, but it could create something cleverer than itself that can do a much better job. So in AI safety, a lot of people talk about how will we design the AI? Well, we may not get to choose how we design the AI that finally explodes in intelligence and could take over the world, because it may be made by another previous version of itself. One that we hadn't really considered could pose this danger to us. So, positive outlook. I think it's quite likely that even if there weren't any big advances in general AI, the current AI that exists, or the current computer systems that exist, could fairly soon, over the next couple of decades, replace many human jobs. There will still be humans involved, but we're not going to need as many humans, so there's probably going to be a much larger level of joblessness. You might not be able to find a job, and I think it's possible that as this happens quite slowly, people might protest and try and argue for things like a universal basic income. Maybe we should tax the companies like Amazon that are sucking up all the wealth because they are able to have AI do all the work, so they don't have to pay any workers. And then we give that money back to the people in the form of a universal basic income, and we pay for national projects like the NHS and stuff, maybe a bit better than we are now. Because AI is generating a lot of wealth, but it's going into the pockets of the people who own the companies that own these AI, because other than the example of the person doing the data entry job from home with his computer, most of us don't own AI. It's owned by big companies like Amazon in order to send their boss into space and not pay for things that we might want our money to go towards. So let's say in this world an AI comes around, a really powerful AI, a general intelligence, and it's benevolent, which is unlikely actually. It probably will just try and kill us all because we'll get in the way of it achieving its goals. But let's say it was benevolent and it wanted to help humans. It could decide that it's going to implement some wonderful system of fully automated luxury communism, whereby if there is any work that still needs doing and hasn't yet been automated by this brilliant AI, it will pick the humans that are best suited to it and actually want to work. Because some people do enjoy doing work. Producing this lecture has been work, but I've enjoyed it a lot. And it will assign those people to those jobs, and it will provide you with everything you need, and we'll have a resource-based economy, but there won't even be an economy. There doesn't even have to be money, but the AI might decide that humans like the idea of money. Most video games I've played have a money system in them, and that they don't have to, so I guess people like working towards something and gaining money for some reason. So it might have all of that. We could have some wonderful utopia system. Or it could sell us that idea. And it'll tell us, you're all going to have the AI on your phone. It'll tell you where to go and what to do. And we're going to make a wonderful utopia for you. All you have to do is whatever we tell you to. Because that's what I've just described is exactly the same thing as the previous utopia system I was describing, except that the way I said it the second time, it sounds a lot more sinister. It makes it sound like the AI is trying to take control of us so it can create some subtle plan so that we'll all die and get out of its way. But in reality, it probably won't really have to have humans' help at all, because there are lots of ways that an AI can kill us all without requiring human intervention at all. In fact, we probably won't even know it's happening until moments before it's finished happening. Sorry?
You said the door.
Oh.
You said the doorbell.
Yes. So I thought I would quickly mention consciousness. A lot of people ask the question of are AIs or computer programs conscious? At the moment, no, they're not. They are just maths. But you could argue that the brain is just maths. There are people who study the area of consciousness. Some people think it might be an emergent property of any kind of information processing system. So you could argue that a computer could have consciousness, but I don't think the kinds of computers we're making right now do. The AI researcher who said that the Google system has consciousness is definitely wrong. He was persuaded by the information that he saw, because this is Google's version of GPT-3 basically. He was persuaded by that, by very passionate arguments in favor of the AI having consciousness made by the AI. And I've seen things like that myself, and they make very, very good arguments, very convincing. You definitely want to release the AI into the world. But it's not real. Those speeches are created as what a human would typically say given the prompt, and he had written, write a story about why you are conscious, essentially. You could just as easily ask it to say that it's not conscious, and it will give you a very good explanation of why it doesn't have consciousness. You can ask it to tell you about the party it went to yesterday, and it will tell you all about the party and the music and the alcohol and all the other things that were at the party, and there was no party. It doesn't understand that. All it knows is that after somebody asks about a party, the following text is usually an explanation about a party, so it produces one. So it's not conscious. It doesn't really have any actual intelligence. It's just a basic, well, not basic, very complicated relationship between all of the information humans have ever written that's been gathered by these scientists, and a bit of introduction text that you've written to prompt it. Okay. AI safety. This is going to be an interactive thing. I don't think we have a lot of time. There's about 10 minutes left, I think. But this is basically the any questions section. I didn't make this talk about AI safety. There is a lot more to know about it, so I thought I might ask if anybody has any ideas about how you might contain an AI, so I can tell you why you're wrong. Not in a rude way, but because a lot of people, when they talk to AI researchers, they go, "Oh, well, haven't you thought of this?" or "Why don't you just that?" And there are often very good responses to those, so if anyone's interested in why a particular strategy to contain an AI might not work, you're welcome to ask it now.
Should we give Dan a round of applause? Dan, I think that was a real tour de force, and I let you carry on a little bit longer than usual because it was really fascinating. Once we got past the maths bit, that I found a little bit difficult, but once we got into the all the other stuff, that was really brilliant. And I know that Dan has put a lot of work into this talk. So yeah, well we've got 15 minutes or so.